We can find the magnitude and direction of the resultant vector by means of rectangular component. To find the magnitude of the resultant vector, we will use Pythagorean theorem. The magnitude of the resultant vector is equal to the square root of the x component square plus y component square plus z component square. The resultant x component is from adding the x component of first vector, second vector, third vector, and so on. Same with the resultant y component and z component. Now, we can get the direction of the resultant vector. Theta x is equal to arc cosine times resultant x component over magnitude. Theta y is equal to arc cosine times resultant y component over magnitude. Theta z is equal to arc cosine times resultant z component over magnitude.
Good day everyone, I am here to explain how we made our program for adding vectors. The vectors that we'll be solving in this video is this. To make the program in Excel, first we should make a table for our vectors. This is vector A, B, C, D. And this should be our component X, Y, and Z. The next thing that we should do is a summation of components. We can use the formula in Excel equals sum, open parentheses, then drag your mouse from AX to EX, and then enter. We can just copy this for X and Y components. The summation of components raised to 2 squared. To do this, we can just equals click the G3 and raise to 2. Copy and paste. And then after that, we can get the magnitude of all vectors by getting the square root of the summation of all squared components. In Excel, type in the formula box equals sum, open parentheses, then drag these answers and raise to 0.5, since raised to 0.5 is equivalent to square root. After we get the magnitude, the next thing that we should get is the direction. We can use the cosine of the summation of components over the magnitude. In Excel, we can just type equals degrees, open parentheses, a cos, open parentheses, summation of x component divided by the resultant, which is 22.69, and close parentheses, close parentheses. For y component, you can just copy, paste, then edit this H7 since our resultant is in H6, and do that also in the z components. Change this to H6, then we're done. Our magnitude for this problem is 22.69 and our direction for x component is 102.73, for y component is 22.28, and for z component is 72.03. To check if the program is working, we could change the values of vectors. We can say that A is 5 and our y component is 6 and z is -3. We can see that the values in our program are changing, thus we can conclude that this program is working.
In this part, we are going to explain how to solve it manually. First, we're going to get all the given, which is vector A, B, C, D, and E. After that, let's identify the formula that we're going to use. So the formula that we are going to use is to get the vector R is equals to Rxi plus Ryj and plus Rzk. And then after knowing the formula, we are going to substitute all of the components. So let's just all add all of that numbers. The next that we are going to do or to find is the magnitude of the vector R. In order to get the magnitude, we are going to use the formula or Pythagorean theorem, which is, let's just square root of the Rxi squared plus Ryj squared plus Rzk squared. Now that we know the formula, we are going to substitute all of the given components. Here we are substituting it, and solve. We're going to solve -5 squared equals to 25, 21 squared equals to 441, and 7 squared is equals to 49 squared. Now let's add all of those inside the square root. It will be equals to 515. Then square root, it will be equals to 22.694. And that will be our magnitude. Now that we already have the magnitude, the only thing left to us is getting the direction. And in order to get the direction, we would use unit vector. The formula for unit vector is lambda is equals to vector R divided by the magnitude of the vector R. That will be the one we solved earlier is, as you can see, the vector R is -5i plus 21j plus 7k divided by the magnitude we solved earlier was 22.694 units. We'll divide each, dividing -5i divided by 22.694, it will be equals to 0.2203i plus dividing the 21j divided by the magnitude, it will be equals to 0.9254j. And 7k divided by 22.694 will be equals to 0.30385k. The last step in solving manually is getting the components or the angles for the vector. Now we will use the formula cosine theta x is equals to vector R divided by the magnitude. Since we are getting the angles for the vector, we'll be using inverse cosine. Now we are going to substitute 0.2203 is the product of the division of vector Rx divided by the magnitude. Now, same process. Now, these angles tells us the direction of the vector.